let's just start with the problems further and we can solve the questions that are related with both the kind of methods. So let's just start with the question number 1. It says factorize this quadratic polynomial. So let's just start with this quadratic polynomial. As we can see that we can write this polynomial x cube minus 23 x square plus of 142 x minus of 120 in the way as x minus of a, x minus of b and x minus of c. We can write it in this particular formation: x minus of a, x minus of b and x minus of c, let us suppose. And we do know that the constant term in this side is nothing but minus of 120, and in this particular side it should be minus of a, b, c if we will expand this particular polynomial. So we can say the constant term over here is nothing but 120, which should be is equal to of the type ABC. Then we have to look out for the factors of 120 or the possible terms of ABC, so that their product should be is equal to 120, as we did in the previous example. So let us suppose I am talking about the possible factors of 120. So what are the possible factors? What are the possible factors of 120? The possible factors of 120 can be, let's just start with the plus minus 1. It can be plus minus 1, it can be plus minus 2, plus minus 3, it can be plus minus 4, plus minus 5, plus minus of 6, and so goes on. There are various factors, or there are many factors of this particular single term 120. So we are not taking all the factors because it definitely would be a lengthy method then after. So we are taking the very first term over here. The very first term is plus minus of 1. So the very first factor is plus minus 1. Let's just substitute plus minus 1 in the given polynomial. So let us suppose I am taking this polynomial as nothing but p of x. I am calling it as p of x. Let's just substitute plus minus 1 in the polynomial and let's just see whether it is satisfying the polynomial or not. So if it is satisfying, then it would be a factor, else it is not a factor using the factor theorem. So I am using the method of factor theorem in order to find out the factors of this particular quadratic polynomial. Now let's just substitute plus minus 1 over here. So let us suppose I am substituting x is equal to plus 1 in this particular polynomial. So p of 1 should be of the type 1 whole cube minus 23 1 whole square plus 142 of 1 minus of 120. Now let's just solve it. It is 1 minus of 23 plus of 142 minus of 120. Now let's just add up the terms which do have the same sign. So 1 plus 142 is 143 and minus 23 minus 120 is minus 143. So this is nothing but is equal to 0. So if it is 0, by using the factor theorem, what we can say? We can say that x is equal to 1 is nothing but a factor. X is equal to 1 is nothing but a factor of this polynomial. It means that we can write p of x, which is x cube minus 23x square plus of 142x minus of 120 in the way x minus of 1, which is multiplying with x minus of b, x minus of c. Now we have to look out for b and c. So let us suppose as we know that we can express this particular cubic polynomial in the way of x minus 1, x minus b, x minus c. So obviously x minus a is a factor of this particular cubic polynomial. So if it is a factor, then it can divide this particular cubic polynomial. So let us suppose I am finding out the further factors by using the division method. How we can find using the division method? As we can see over here, this cubic polynomial can be written as x minus 1, x minus b, x minus c. So obviously x minus 1 can divide this particular cubic polynomial, and after the division the quotient will be nothing but x minus b into x minus of c. So let us suppose I am using the division method. We have x minus 1 and further we have x cube minus 23x square plus 142 of x minus of 120. So let us suppose I'm writing minus of 120 over here. So let's just start dividing these terms. So we know that we have to divide the very first term of the dividend and the divisor. So x cube divided by x is nothing but x square. So it is x cube minus of x square. Now let's just change the signs of both. So it will be minus, it will be plus. Both the terms get cancelled with each other. So it will be nothing but minus 22x square plus of 142 of x minus of 120. Again further we can say it is minus 22 of x. So it is minus 22 of x square plus of 22 of x. Now let's just change the sign. So it is plus, it get cancelled, it is minus. So this is nothing but x and 0 and 2 and 1. So it is minus of 120. So it is plus of 120, and at the end we get 120x minus of 120. Minus get cancelled, plus get cancelled. The remainder is nothing but 0. So hence at the end what we can say that we can write this particular cubic polynomial p of x in the way x cube minus 23x square plus 142 of x minus of 120 as x minus 1, that is divisor into the quotient, and the quotient is x square minus 22x plus of 120 plus of remainder, and obviously the remainder is nothing but is equal to 0. So it means that x minus b into x minus c is nothing but is equal to x square minus 22x plus of 120. This is a quadratic polynomial, and we can find the factors of the quadratic polynomial using the factor theorem or either using the middle term splitting method. So let us suppose I am using both of these methods. So I am now using the middle term splitting method in order to find the factors of this particular quadratic polynomial. So let us suppose we are using the splitting the middle term method for this quadratic polynomial. We have the quadratic polynomial as x square minus 22x plus of 120. Now we have to look out for the two terms p and q in such a way that p plus q should be is equal to of the type 22, and their product should be mandatory is equal to of the type 120. So let's just look out for the two terms whose product should be is equal to, let us suppose we are talking about any two terms PQ whose product should be is equal to AC. A is already 1 over here, C is nothing but 120. So we have to look out for PQ which is equal to 120, and P plus Q should be mandatory is equal to 22. Now let's just look out for the factors of all these terms. So let us suppose we are talking about 22. We can write 22 as nothing but 2 into 11. So the two numbers P and Q are definitely 12 and 10, because 12 into 10 is nothing but 120, and 12 plus of 10 is nothing but is equal to 22. So it means that in place of B we can write P plus Q which is equal to 12 plus of 10. So let's just write this quadratic polynomial as minus of 12 plus of 10 minus of 12 plus of 10 of x plus of 120. Now let's just expand it. It will be x square minus 12x minus of 10x plus of 120. Now we can take the terms common. Let us suppose I'm taking the first two terms. Let's just take the term x common out of it. So it is x minus of 12. Let us suppose I'm taking minus 10 common out of the second bracket. So it is x minus of 12. So at the end we can take x minus 12 common out of all the terms. So it is x minus 12, x minus 10. By using the middle term splitting method or splitting the middle term method, we actually have found the factors of this particular quadratic polynomial. So it means that in place of x square minus 22x plus 120, we can write it as x minus 1 into x minus 12 into x minus of 10. Let us suppose I'm calling this particular equation as equation number 1. So we will write using equation number 1, we can say that this particular quadratic polynomial can be written in the formation of x minus 1, x minus 12, x minus 10. So at the end px is nothing but is equal to x minus 1, x minus 12, x minus of 10. So this is nothing but our answer, and these are nothing but the factors of the given cubic polynomial. So using both the kind of method or using a single method, you can find out the factors of any particular polynomial. So for the cubic polynomial, I actually have used both of these methods all together. So at first I have used the factor theorem, and at the end, in order to find the factors of the quadratic polynomial, I have used splitting the middle term method. So you can use any kind of method in order to factorize the given polynomial. So I hope all the steps of this particular solution set is all clear to you.